So hello guys, my name is Aditya and we were talking about NumPy, the NumPy package, and up to the previous video we have covered these 6 topics, and I said that we'll be covering these 3 topics in the next video, but I realized that we are missing something, so I have added this 10th point, which is really very important, and we'll be covering this in the 4th video. So for today we'll be covering these 3 topics. So let's directly jump into it. I have already imported NumPy because this was a fresh kernel. Now, flattening any n-dimensional array. So let us just take an n-dimensional array. Let me just copy it from somewhere. Yes. So this is my 3-dimensional array, as we can see, right? This is a 3-dimensional array, and it also shows here that it is 3-dimensional array. Okay, now if I want to flatten this array, what does flattening means? That will keep a single dimension where each element is present after another element, like after 23 directly 2 will be present. It will not be in a separate list. Okay, so what we can do is we can just write arr0 dot reshape and we pass here -1. Okay, if you directly pass here -1, it will flatten any n-dimensional array. So it has flattened, right? So this is how we flatten any n-dimensional array. We just pass -1 as a parameter. Okay, now we'll talk about joining arrays and stacking arrays. So let me just have 2 arrays. arr1 is assigned to np.array, and let me just keep here 1 2 and 3. Okay, and let me have arr2, and let me just keep here np.array 1 not 1 5 6 7. And if I want to join this array means after 1 2 3 5 6 and 7 should occur. Okay, then what I can do is, and I want to store it in a new array. Okay, so let's say arr, so np.concatenate is the function. Okay, con concatenate, and I want to concatenate this array with this array. That means first this array should come, the elements of this array arr1 should come, and then the elements of arr2 should come. Okay, so I'll first write arr1 and then I'll write arr2. Let me just print arr and let's see this is how concatenation is done. Okay, so what if I want to what if I want that arr2 should be present before arr1? I'll directly write arr2 here and then I'll write arr1 here. Okay, let's see what is the case for a 2-dimensional array. Okay, so 3 and 4 here, and let me write 7 and 8 here, and let me make it 2-dimensional array. Two-dimensional, this is also 2-dimensional. Now what this will do is, just like here, see, after 1 2 occurred, after 2 3 occurred, right? And then after 3 5 occurred. If we were doing this arr1 and arr2, after 3 immediately 5 occurred, then after 5 6, then after 6 7. So it printed in this way. Okay, what this will do is it will concatenate the inner arrays. Okay, so after 1 2 3 4 will occur, but it won't occur as a single element, it will occur as an array. Okay, and then 5 6 and then 7 8. If I just do here arr1 and arr2, okay, after 1 2 3 4 occurred, after 3 4 5 6 occurred, and after 5 6 7 8 occurred. Okay, so this is how we can concatenate two-dimensional array. Same, it works the same as one-dimensional array. Now this was concatenated using the rows, right? This became the first row, this became the second row, and so on. What if we concatenate using the columns? How can we concatenate using the columns? We just have to write axis is assigned to 1. See, in Python, most of the time this axis variable is used, even in NumPy, even in pandas, even in Seaborn and many other libraries. This axis variable is used. Axis variable simply means that if you assign axis to 0, it will do row operations. If you assign axis to 1, it will do column operations. Okay, so uh, and by default the value of axis in most of the packages is 0. So even if you don't write axis is equal to 0, it does the same thing. Even if you write axis is equal to 0, it will do the same thing. Axis 0 means operation towards the row. Okay, what if I write axis is assigned to 1? Then it will perform the operation towards the column. So first it will join these two columns. Okay, and then it will return this. Then after that it will join these two columns, and then it will return this, and then it will concatenate both the arrays. So this is how concatenation works. Okay, concatenation simply means joining the arrays without changing the dimension, okay. Now if we want that we want to stack two arrays, like I want to keep this as a separate array and I want to keep this as a separate array, but I want another array of a new dimension where this should be my 0th index and this should be my 1th index. Okay, so I cannot concatenate them because it will make it a single array, so I have to stack them. Okay, I have to stack this above this. So what I will do is I'll just copy this and I will stack them. So I'll use a stack function. So this is stacked over this. Okay, and the dimension changes from 1 dimension to 2 dimensions. So this even if you don't write axis here, axis 0 is by default, so it will work the same. But if I write axis 1 here, then it will join these two, sorry, not these two, these and this, and it will join this and this, and similarly it will join this and this, and it will stack these two above these two and these two above these two. Okay, so you'll know what I'm trying to say. Okay, so it joined 1 and 5, and then it's stacked over 2 and 6, then 2 and 6 is stacked over 3 and 7. Okay, so this is how stacking is done. Now but see, stacking changes the dimension. What if we do not want to change the dimension? Okay, what if we do not want to change the dimension and still we want to stack? That means similar kind of just like concatenate. So that is why we have at stack and v stack. At stack means horizontal stack towards the row, and v stack means towards the column, stacking towards the column. See, it is same as concatenate, right? Concatenate with axis 0, and if I write this and I put here axis 1, then it will stack vertically. Oh, we don't have an axis in at stack and v stack. Okay, it is already said that h means horizontal, that means towards the row, and v means vertical, that means towards the column. Okay, so this is how we get towards the row and towards the column. So but see, we don't use this at stack, v stack, stack and concatenate most of the times. We may use if it is required, but generally it is not used. I personally I have not used it much till now. Okay, so it may be used. There is a function, so it may be used depending upon the requirement, but these are not the most used functions. The most used functions are what it is coming in the next video. And also this 9 point, the where thing we use a lot of times. Okay, so let us know what is the where thing. Okay, so let me just get this array and let me write 6 5 3 2 1, anything. Okay, and if I want to know the index of 3, then how can I find the index of 3? One way is to iterate through the array. Okay, and we'll compare that. If this is 3, then return the index. If this is 3, then return the index. If this is 3, then okay, return this index. Okay, and in this way we can compare with every element and we'll get the index as 2 0 1 2 3 4 5. So we'll get 2 and 5. Okay, so what if we don't want to iterate, and since we have a NumPy package, so we can directly use a, let's say, index. Okay, it's just a variable, nothing else. np.where arr modulus, no sorry, arr is equal to 3. So this should return the indexes. Okay, the index 2 and the index 5. Okay, so I was missing ARR1 here, that is why it is showing me something like this. This is not ARR, this is ARR1, right? So now we get 2 and 5 as the index, what we were wanting earlier, right? Because at 2 index we have 3 and at 5 index we have 3. Sorry, at 5th index, this one, we have 3. So it returns an array of indices where 3 is present in the ARR1. Okay, similarly, if we want to find the indices of the even numbers, then what we can do is, I'll just copy this code and I'll write ARR mod of 2 is equal to 0, right? So this returns even numbers. So at this position, at 1th position we have even number, at the 3rd position we have even number, and at the 6th position we have even number. So 1 3 and 6 should be returned here. Okay, well and good. This is how we use the where clause. We by using the where clause, we just find the indices depending upon the conditions given here. Okay, we find the indices in the array depending upon the conditions given here. Now we are done with the where clause. Now we'll talk about search sorted. Now what is search sorted? So let me just have this ARR1 and I want to sort this, because this search sorted only works with a sorted array. Okay, so let me just print ARR1. So I have the sorted array here. Okay, now if I want the correct position to insert something, like suppose if I want, let's say x is assigned to np dot search sorted. Okay, and in ARR1 I want to insert, let's say, 4. So what should be the correct position to insert 4? At this position, right? At this position, between this 3 and 5. That means after 3 and before 5. So the index of 3 is 0 1 2 3 4 5. So it should return 6 to me. Okay, so this is the advantage of search sorted. It returns in the sorted array the correct position of this element, such that the array remains sorted. Okay, it does this by applying binary search. So let's not get into binary search now. So this is done by using binary search, but the idea behind search sorted is it gives us the index at which it should be present in an already sorted array such that the array remains sorted again. Okay, so this should return 6. If I print x here, this should return 6. Okay, let me just delete this cell and let me just write here x. Now what if I want the correct position of 1? So let's try this, because there are multiple ones, right? So it gives us 0, because if we insert before this one, then there is no problem. Even if we insert 1 here, it remains sorted. What if we want to get the index of 3? Okay, 3. So it gives us 4, 0, 1, 2, 3 and 4. So before this 3. Okay, so this is how this search sorted works, and I hope you understood this, and I also hope that you like this video. Tomorrow we'll be continuing with some of the functions of NumPy, okay, like the mean, mode, average, and standard deviation, variance, and some other functions as well. Okay, so I hope you like the video. If you actually like the video, hit the like and the subscribe button. Also share it with your friends. So have a great day ahead. Thank you for watching. We'll see you soon. Bye bye.